Alright, welcome back guys. So in this video, we're going to continue where we left off, and that was this example 1 part B. It is asking for what is the IQ score that corresponds or at the 90 percentile. So to do that, we looked at what the score at the 90 percentile, how many standard deviation is that above the mean. So we're going to use a z-score table to find that z-score that corresponds to the 90 percentile, meaning an area to the left that is 90%, or the score that is higher than 90% of all the scores. Okay, so we're gonna go to the z-score table, and then we're gonna locate an area of 90% and see how many standard deviation, what z-score that is above the mean. So let's go to the z-score table here. And then we're gonna go ahead and locate an area of 90%. So area is in here. We're gonna find 90% in there, and we know that this IQ score or the z-score is above the mean, so the z-score is gonna be positive. Okay, so it's gonna be positive. Let's look for 0.90. So I see 0.8997, and I see 0.9015. We're gonna go with the one that closest, or the one that the nearest to 0.9. So 0.9 is gonna be, this one is gonna be the closest one here, 0.8997, and then we're gonna backtrack that to a z-score. Okay, so that's gonna be at 1.28. Okay, so it's gonna be at 1.28 is a z-score. So 1.28. So a score that is at the 90 percentile is 1.28 standard deviation above the mean of all the scores, or the IQ score. So we're gonna go ahead and convert this back. So when we say convert this back to an IQ score, using this formula, z equal to x minus mu over sigma. So now we have z is 1.28. We want to find what is that a value, or what is that x value, the IQ score. If the mean is 100, standard deviation is 16. So multiply both sides. So multiply this here by 16, add 100. So a is 1.28 times 16 plus 100, and that score there is 120.48. So if someone has an IQ score of 120.48, then that person is at the 90 percentile, or that person's score is greater than 90% of all the IQ score. Okay, so that is the answer for part B. All right, moving on to question 2. So I'm going to speed this up a little bit. I'm going to start using the command on the calculator to get the answers. So you're probably going to want to pay more attention on this part here. Makes it work so much easier. We're going to get the answer really quick and easy, but focus more on the interpretation of the answer. Okay, so in example 2, according to the survey data, the number of hours sleep students report getting per night is normally distributed. We say that a data set of number of hours students get per night is normally distributed, and a mean of 7 and standard deviation of 1. So we say that distribution x is number of hours of sleep student get per night. Okay, and then mu is going to be 7, sigma is going to be 1. So if we were to draw that distribution, it looks like this here. And then this is x, so it's somewhat normal, right? We're given that's normal. Now we asked to find what is, so we'll say if x is 5, if a student gets 5 hours sleep per night, what percentile is that? Meaning, if the student has a 5 hours sleep per night, what percentage of other students that has less number of hours sleep per night than this or greater than? So in other words, we're looking at this here. We're looking at here 6, 5, so 6, 5. We're looking at So 5. We're looking at this area here. So what is that area? So to find that area is the same thing asking a question, what is that percentile? Okay. So we can do the long way or the short way. Here is the long way. Let me explain the long way here. So the long way would be convert x equal to phi to z-score. Okay. Use z-score to look up area. Okay. Then okay, so and then we'll say that area corresponds to that z-score. The z-score is the percentile of x equal to 5, or a student that had 5 hours sleep per night. Okay, so what we're going to do is we're going to use a calculator command to get the answer. Okay, so here is the calculate command. Okay, all right, so we're going to use normal CDF, because it's normal distribution. Okay, it's going to be normal CDF of negative 999 to 15. Excuse me, let me go ahead and erase this. You know what? I'm going to erase all this here. I'm going to get some space here. All right. So I'm going to go ahead and say use the command normal CDF of lower bound, upper bound, and then mu and sigma. That's what we want to use. Okay, so do a second distribution, second and vars will bring up the distribution, and then you type in normal CDF of what is the area to the left of phi, meaning we're going to start as low as negative 99, the lower bound, up to 5 hours. The mean is 7. Standard deviation is 1. If we type this into your calculator, then that will give us the area to the left of phi, and that is 0.0227. That's about 0.03 or 3%. So going back to the answer, this is at the 3rd percentile. Okay, so the confusing part is, where does this come from? So this is like saying that what is the part where the graph touches the ground here? So we're going to be safe and just call that negative 99 to be safe. So this is the low bound, this is the upper bound, this is the area to the left of phi, or the area between negative 99 to phi. So it depends on which area we're shading. If it's toward the right of phi, then we go from phi to 99 or 9,099 to be safe. So it's just a technical command that we use for normal CDF. This is a lot faster to, to convert this phi to a z-score, and then look up the area that corresponds to that. It saves some time by doing this here. See, it's even more better once we get to these problems here. Okay. So how much time do I have for this video here? So I have about a minute left. So I'm going to quickly just kind of go through part B here. To be at the 75 percentile distribution, a student needs to sleep about what hours sleep per night? So this is going to be find x. So say that find x corresponds to 70 percentile. So that mean what is the number of hours sleep per night that is at 75 percentile? That means area to the left is 0.75. Okay, this area to the left is 0.75. Okay. So what is that x value? Okay. To do this the long way, we will have to convert. Actually, we would have to look up. We have to look up a z-score corresponds to to area of 0.75, okay, then convert z-score to x. Okay, so that would be the long way. The short way would be use this command, or use this command of invert norm, and then this is under the distribution list again. You could go second vars will give you distribution. You bring up the invert norm. This is option, I believe that's option 3, invert norm, and then we're gonna say invert norm. Okay, what is the score of, what is the number of hours sleep a student get per night that correspond to at the 70th percentile, so that's 0.75, and then this is going to be the mean will be 7, standard deviation is 1. So this is your mean, and then this is your standard deviation. This is the area or percentile. So if we do this on our calculator, it will give us an x value that is at the 75 percentile. So that x value is 7.67. So the answer for this one is that a student needs to sleep about 7 hours, 0.67 per night, to be at the 75th percentile. So that means 75% of the student receive or get about 7 hours and 67 minutes or lower, 7.67 hours or less. That's another word what this is saying. Okay. Oops. Box that one there. I'm going to go ahead and end the video on this one, and the next one I'm going to go over the next example.